Section 9.3, the parabola. Now, I know you think you know everything there is to know about a parabola. You've done parabolas since Algebra 1. But there are a few things you don't know. So hopefully, I know you'll learn something new here, and we'll learn a kind of a different way to graph them. Okay? So let's first get the definition of a parabola. A parabola is a set of all points in a plane that are equidistant from a fixed point. The fixed point is called the focus. And a fixed line, which is called the directrix. Okay, parabola is a set of all points in a plane that are equidistant from a fixed point and a fixed line. Please sketch this diagram. You see the x-axis essentially, maybe it's just a horizontal line, but yeah, the x-axis. The vertical line there is not the y-axis, okay? The little red point is the vertex, and you all know that a parabola has a vertex. And the green point is the focus. So we see here's the vertex and the focus, and the parabola is a set of all points in a plane that are equidistant from the fixed point, the focus, and this directrix. There's the line. Okay, there's the directrix, this line we're talking about in the definition. So originally you have a point and a line, the green point and the black line. Now we all know, oh, that's not the x-axis, I'm sorry, that says axis of symmetry. We all know that a parabola has an axis of symmetry. So the red line is that axis of symmetry. Now let's see how this definition works. Sorry. Essentially, every point on the parabola is equidistant. What does that mean? That means the distances are equal. So the distance from this blue point to the directrix is a perpendicular, because the distance from a point to a line is the perpendicular segment. And then the distance from the focus to that point, we're telling you those two pieces are congruent. Those two distances are congruent. That's exactly what the definition says. So any point that we choose on the parabola, its distance from that directrix and its distance from the focus, those two pieces are congruent. Are you seeing it? So that's how we get all these points. So any of these points, the distance to the directrix, the distance to the focus, those are congruent. I'm looking in here and I see little green hash marks because there's the vertex right in the middle. I mean, the red point. Here's the vertex, and it is also equidistant from the directrix, right there, the little part of the segment, and equidistant to the focus. So they're all three, that's all on the same line. You see it? The focus and vertex are both on the axis of symmetry, and that intersects the directrix in a perpendicular. So vertex is the midpoint between focus and directrix. So there's a lot going on there that you never knew, I'm sure. Okay, so there's the definition. I'm sure you sketched that, and we'll move on. The next question says, describe the axis of symmetry, the directrix, and how they are related to each other and to the parabola. So here's the description. The axis of symmetry intersects the parabola at the vertex and bisects the curve. The axis of symmetry is perpendicular to the directrix and also contains the focus. So we said that as we described it in the diagram, and so write those sentences now into your notes. Reading it one more time before we turn the page. The axis of symmetry intersects the parabola at the vertex and bisects the curve. The axis of symmetry is perpendicular to the directrix and also contains the focus. All right. Now, the equations of a parabola. You've spent a whole lot of time on the function that's a parabola, which is the y squared. I'm sorry, y equals x squared. That's the one you spent a lot of time on, the one that is a function. You do know there exist the ones that go left and right. So we're going to treat them essentially equal here. And so please, the equations with the vertex at the origin, that's important. With the vertex at the origin is y squared equals 4px. Now I understand you don't know why we put a 4 there and that p. We'll explain that in a few minutes, okay? Here's the general form for the equation of a parabola with the vertex at the origin. Y squared equals 4px. In that case, the y is squared, and if the px, the 4x is positive, it's going to the right. If the 4p is negative, it's going to the left. So essentially just the p. If p is positive, if p is negative, right and left. Then there's the form, this is the form you've been used to. I know we got the y, the x squared is on the left, but the y is a linear term. And so this is the form you've been used to, the one that's up and down. So x squared equals 4py. And the conditions here are if x is squared, then 4p is positive, it's going up. If 4p is negative, it's going down. So that tells you, that's the equations and the description of how you know which way the parabola is oriented. Give you a moment to finish copying that. Okay? All right, now we have the table to fill in when the parabola's vertex is not at the origin. The parabola's vertex is HK. Now we've used that same order pair HK for the center of the circles, the center of the ellipses, the center for the hyperbolas, and it is the vertex of our parabolas. So here we go. This is your table. So the two equations, two forms of the equation are y minus k quantity squared equals 4p times x minus h. This other version, when the x and y are switched, then it's x minus h quantity squared equals 4p times y minus k. The axis of symmetry for the one where the y is squared is a horizontal line, y equals k. For the one with the x squared, it's a vertical line, x equals h. You will have to name axes of symmetry in different situations, so you need to know how to do that. And then the focus, excuse me, here is the way you would find it, but you do not have to know that. We're not going to do it with a formula. We're just going to do it essentially by sight, and you'll see what I mean, okay? But go ahead and write that in. It's got a box around it here like, okay, we're not going to really focus on the focus. We will use it, and you will label it, but you won't need to know this particular formula, the way we're going to do it, okay? But go ahead and write that in the little table. The vertex in either case is HK, and we kind of already said this part, but if P is positive, then this one goes to the right. We're talking about the one with the y squared. If P is negative, then it goes to the left. And in the second case where X is squared, if P is positive, it goes up. P is negative, it goes down. Okay? So your table will be filled when you get those written, and I've got a little thing over here on the side. It says, here it comes. Do not turn the page. You got a space at the bottom of your notes right there. We're going to write something there. This particular term, I'm going to wait. Has everybody gotten that copied? I'll give you another few seconds here to finish copying that before I start this. Okay, all the little details about each set of equations. So you know each of those boxes has two things. The top one applies to the y squared, the bottom one to the x squared. All right, so here it comes. The ugliest mathematical term in the world. Okay. This is just the ugliest word on, asymptote's a pretty bad word, a pretty ugly kind of word to just say and roll off your tongue. Well, here comes one that's worse. It's the latus rectum. The latus rectum, and that's about all I'm going to say. I'm not going to say it again. We call it the LR. All right. So when we start using it in the formula, in the graphing, we just say LR. Okay. So it is equal to the absolute value of 4p. The sign of 4p makes it go up, down, left, or right. After we get the sign off of it, the sign's doesn't affect anything anymore. So that's why there's an absolute value around that. Okay. Now, here's what it is. It's a chord of the parabola that is parallel to the directrix and contains the focus. Okay? So essentially, if you have a parabola, let me start that over. Let me give you an analogy. Okay? Everybody knows Atlas. He's holding up the world, right? He's strong. Atlas. Well, imagine you have a line, and then Atlas is standing there in the middle. Could draw him, but I'm not. And he reaches and grabs one side and reaches and grabs the other side and begins to pull upward. So as he pulls upward, that line turns into this. Okay? Now imagine your bodybuilder, the strong guy, the weightlifters, in the Olympics, let's say, or any of those guys who do that powerlifting. They always wear something around their waist. They wear a belt. And the latus rectum essentially is the belt that's holding that side and this side up. Okay? That's what it is. It actually, the root word of it means a belt. So it's holding up the left side, and in perfect symmetry for your parabola. So that's where it is on like LR. Okay? So you can sketch that so you understand kind of what we're talking about. A chord. Remember, in a circle, a chord is a segment that touches that intersects the circle twice, and it's on the interior. So that's a chord of the parabola. All right, so let's see how we're going to use that to learn to graph. So I'll let you get this one set up. We want to name the vertex. We want to name the direction, of course. We want LR, and then we're going to take LR and solve for P. Okay? So let's do this. Looking in that equation, and let me read the equation, x plus 1 quantity squared equals -8 times y plus 1. The vertex is HK. Please remember the H comes from the X parentheses and the K comes from the Y, because when they're switched, you have to reverse that way you gather them, okay? So right here, we see that says +1, so this makes this -1. In the Y, we see that also says +1, so that makes this -1. So our vertex is -1, -1. Okay, direction. This is x squared. So if x is squared, does it go up, down, or left, right? You got to think it through or go back to your table. If the table on the other side of your notes, if x is squared, it's going to go up or down. Then where do we look? We look right here at that negative sign, and it's negative. So the direction for that then means it's going to go down. Okay? And then we look up there and we see the number in front of the parentheses of the linear term is -8. So remember we had absolute value there. So the absolute value of that is 8. So 4p equals 8. So what's p? Well, divide by 4. P is 2. Okay? And we'll need that 2, and we'll need the 8 in just a second. So here we go. Ready to graph? On the graph, let's put the vertex. -1, -1. Okay? Now, from this is our vertex. Label it V, because we're also going to put the focus on here. So from that, you see down, I'm going to go down 2 from the vertex. 1, 2. I just found the focus. Put an F by it. There's the focus. Okay? So you see how we combine the direction and that value of P to locate the focus. And now at the focus is where the LR is located. It is stretched across. Now remember, this is going down, so it's going to be opened, curvature downward, and I just need to know how wide it is. Well, guess what? The LR is 8 units. If the LR is 8 units, but the focus is the middle of that 8 units. This is 8, but the focus is the point in the middle, so how far will this side be, and how far will that side be? Okay, you got it? 4 and 4. So from the focus, I'm going to go to the right 4. 1, 2, 3, 4, put a point. Going to the left 4. 1, 2, 3, 4, put a point. And now I have 3 points of my parabola, and I'm going to sketch the parabola. And you see how the focus sits right inside. There's your parabola. That's how we're going to do it. Okay? I understand this is new. It's a new way to do this. That's okay. You're learning. And here we go. Let's do another one. Give you a second to finish that. Okay, I need to review. Easy getting the vertex on there. Then you find the direction and the value of P. So from that vertex, you're going to go down 2, and there's your focus. At the focus is where the LR is, and it's perpendicular to that axis of symmetry. By the way, see, this would be the axis of symmetry, right? And if you're interested, the directrix is 2 units on the other side, so the directrix is right there. You see, and the vertex is halfway between the focus and the directrix. That would be D, and this is our line of symmetry. Okay, and now the chord, that's the LR, is perpendicular to the axis of symmetry right there. So there's all the parts of a parabola. You didn't know it had so many parts, did you? Okay, let's move on. Now, this one says y plus 3 quantity squared equals 12 times x plus 1. It's already on your paper, so let's go ahead with V, the vertex. Now, careful. The y is on the left and the x is on the right, so you got to go over here and find the h. It's going to be -1, and look there and find the k, -3. So our vertex is -1, -3. And now we need direction. Okay, well, the 12 is positive. And the y is squared. So this one's going to go left, right. And if it's positive, that means it goes to the right. And LR equals 4P, and 4P is 12 from our equation up there. So that makes P equal to 3, right? 4 into 12. And now we're ready to graph. Vertex, -1, -3. Okay, put a V by that. And now we need to go to the right. How many units? To find the focus. To the right, 3 units. 1, 2, 3, and there's F. Okay. Now I go in the perpendicular direction from the way I went to the right just then, so I'm now going to go up and down. And here is the length of LR, so the focus is the middle of it, so I'm going up half of that, 6. 1, 2, 3, 4, 5, 6. And down 6. 1, 2, 3, 4, 5, 6. And now we will sketch in the parabola. You want to make it as nice curvature, but these don't go up like a lot of times you're like a horseshoe kind of thing. They seem to be going out, and they should. They should be going out. Okay? I'll give you another second there. We found the vertex, being careful finding the x part and then the y part, -3, -1, -3. Then to find the focus, you find the direction and the value of P. You go to the right 3 units, and there's the focus. And then you use the length of the LR and half it and go up and down or the opposite directions. That distance, it gives you 2 points on the parabola. And there you go. You can graph it. Now, what if it's not in parabola form? What if it's in general form and, oh wow, we got to do some stuff to it. So let's discuss. Y squared plus 2y plus 4x minus 7 equals 0. Look and see which one is squared. Well, there it is, y is squared. So we're going to leave the y terms on the left, and we're going to take everything else to the right. So y squared plus 2y, leave us a little bit of room, equals, and put the 4x and the negative 7 on the other side, which that makes that a negative 4x and a positive 7. Make sure I'm doing that right. Okay, and now on the left is squared, so we're going to complete the square. So if I want to complete the square here, I look at the 2, and half of 2 is 1, 1 squared is 1. So inside we will add 1. Is that really a 1? Well, yeah, that's just a 1. Nothing's in front like previously we've had this week. Okay, so that's just a 1. I added it on the left. I have to add it on the right. Okay, and now let's complete the square on the left. So that's just plain old x plus 1 quantity squared. All right, that was nice. And then now we get negative 4x plus 8. But I now need to factor out whatever coefficient x has. So I'm factoring out the 4 and writing in parentheses just x, because that one needs to be linear. I mean, just a 1x inside the parentheses there. And what will the 8 become? Well, negative 4 into 8 is negative 2. And rewrite the right-hand side. And there you go. Okay, does everybody see how the parts moved and have moved there? So what is the vertex? Did you get 2, negative 1? Hope you did. Okay, which direction is this? Well, it's y squared, so it's going to be left right. But 4p is negative, so that means it's going to go left. Okay, and what is the value of LR? 4. And that's 4p. Okay, 4p equals 4, so that means p has to be just 1. Now I know you don't have a graph, but let's graph one more. Okay, so help me graph this one. Vertex is negative, it's positive 2, negative 1. There's the vertex. The focus is to the left. How many units? Just 1 unit. There's the focus. And at the focus, the parabola is how wide? Well, it's 4 units wide, but so from the focus is the midpoint of that. I need to go up 2, down 2, and there are my 3 points for a nice little parabola. Okay? Getting the hang of this? All right, let's do one more. Give you a few minutes to start this one. Start setting it up and working it yourself. X squared minus 2x minus 4y plus 9 equals 0. Be careful with the terms. Which side did they go on? And then complete the square. I'm watching the clock, trying to give you about a minute. You might be finished already. I know dead air on a recording is pretty boring, but you're working. 10 more seconds. Okay, let's see. I think it's up here. What did we do? Well, we put the x squared and the negative 2x on the left by themselves. We took the minus 4y, put it as a positive 4y on the right, a positive 9 as a negative 9 on the right. And then we completed the square. Half of 2 is 1, 1 squared is 1, so we added 1 here and 1 on the right. Completing the square, that's x minus 1 quantity squared. Let me caution you over here. I have students, and they do it on the test and quiz. They go ahead and try to take out the 4 in front of this y too early. Please wait until you complete the square, get the term over there, combine them, and then start taking out something, okay? So you see we added negative 9 and 1 and got negative 8, and now a 4 will come out of that. But if you forgot to do this, even sometimes students forget to write the thing on the other side, and then they're trying to take a 4 out of 9, and you get an ugly number. And I don't think many of them even do that. You just forgot something, and that should kind of give you a heads up that, well, let me go back and see if I made a mistake, okay? So now we'll factor out the 4, and we get 4 times y minus 2. The vertex of this would be positive 1, positive 2. All right? Okay, hope you were successful with that. Now let's move on. There's something else at the bottom. You watched a video earlier and saw the conic sections kind of generated with computers and models and all kinds of things. And they did talk about degenerate conic sections, but we're going to write them here. What are the 3 degenerate conic sections, and when do they occur? So here they are. There's the double nape cone. And the degenerate conic sections are a point when the plane passes through the vertex. So if your plane is a horizontal plane and then all of a sudden it passes through the vertex, you just get that point right there. So it can be a point when the plane passes through the vertex. Or it can be a line when you have the plane that's getting the parabolas. So you're passing through here these ways, the way the line's going, and then you get to this point right here, and you're going down the edge of that one, your tangent there, and your tangent to the second nape. Then you just get a line. And then with the plane that is a vertical plane, full plane going through both napes, and you're getting the hyperbola, if you go through the vertex here, you're just ending up getting intersecting lines. Now, you did see that generated on with the computer stuff, but please write these down in your notes, okay? Intersecting lines when the plane parallel to the axis passes through the vertex. So notice each of those happen when it passes through the vertex, passes through the vertex, passes through the vertex. So that's kind of the degenerate case, is when any of those pass through the vertex. You get a weird picture that's not one of our standard conic sections, the 4 that we have studied. Okay? All right, I'm going to assume you have finished writing that. Somebody can pause it if somebody in the room is not done. Moving on, you have a quiz coming up, and these are the 4 conic sections that we have studied, and these are on the quiz. It's tomorrow. There's the equation for a circle. I don't know why it says circles and all the rest of them are singular. I apologize. Maybe I can erase it. I'm not sure if it'll erase. Okay, good. Now, I don't like bad grammar. So, there's the equation of a circle, the equation of ellipse, hyperbola, parabola. You may want to copy them down. You're going to need to begin to learn to look into them and see what's going on and recognize which is which when you look at an equation. And you see with the that will be one of the next skills that we do after the quiz. All right? But there's the 4 standard equations. I know I didn't flip the x and y. I didn't give you the other version of it. Okay? But especially for the hyperbola and the parabola, they have a second version. The ellipse and circle, those don't flip. They just, the values of some numbers change. In the ellipse, the a squared and b squared would flip. All right? So those are the nice, pretty forms of those. And you have them in your notes, so I'm going to move on. Here's your assignment, and there's a quiz tomorrow. If you want to go back and study some circles that's on page 250. Ellipse is at page 912, and we've just recently done hyperbolas and parabolas. So there's the parabola homework. Quiz tomorrow. Please study. You will be graphing at least 2 of each one, okay? And you might have to look at a graph and decide what its equation is. So go back and study and look through those. Thank you, and have a nice day.